Okay, let's start then. Good afternoon to everyone, and welcome to the demo session for Oracle Performance Tuning. My name is Mukesh Kumaja, and I will be the trainer for you for performance tuning training. And I have 15 years of experience as an Oracle DBA and more than 10 plus years experience in performance tuning. I've been doing performance tuning at the query level, at the database instance level, and I've worked on multiple Oracle versions starting from 8i till 19c. And uh, as a DBA, I've worked on multiple projects, multiple organizations I've worked with, and I have experience of interacting with international as well as national clients. So that is about me. And if everyone can say your yeah, what is the control and what is your years of experience in performance tuning. So based on that, we'll get a clear idea what this group has. Okay, two persons. Srinivas is senior database administrator with 10 plus years, and Sriram is 8 years experience and not a good chance to work on PT. Okay, no experience in PT. So the reason why I'm asking performance training, because performance training is completely a different uh, part of the DBA activities. Many of them are not comfortable in doing the performance training. Even when I started when I was almost 3.5 years of experience as an Oracle DBA. After 3.5 years of experience, only I started in PT. So it looked like a bit of a difficult job to start with because it requires a lot of doing the analysis, knowing the SQL queries, knowing the PL/SQL queries, how that SQL queries are written, how do you write PL/SQL codes, and then what do you do as a PT? Because if I'm not wrong, there's no document either from the Oracle side or either any blog available that which gives you a dead cut or exact steps to how you need to go through the performance thing, how you need to do it, because this is it is completely different for every scenarios. Even the experienced ones who have been doing for a long period of time, every time when the performance comes, it's every time a new thing. Only the thing is, based on your experience, we'll get to know where to start, how to start, and how do you analyze it. Where do you start with? So those who have already worked in PT, may I know if I'm right or wrong on this part? And PT is not a thing where it is documented everything that you need to go step by step. It is completely new every time when you face the performance issues. What is your experience? What do you say? If you agree with me, then type yes. If you don't agree, type no in the chat. I'll just share my screen. Okay. So Shiva is agreeing with me. So okay. Now I'll start with the contents of the performance training course which we'll be going through during our classes, and what it contains, and how what will be the approach of doing it. Now, those who are already into performance tuning, they know a bit of it. That whenever we face an issue, so at what level it is, whether it is at the database level or whether you're doing a query performance tuning, then how we need to start it. The very first thing is uh, how we need to start it. Do we need to look at? And for those which is who are not don't have any experience on this the PT part, so it is a very new thing for them. But we'll go step by step with the base, starting with basics. So we'll go step by step. Those who are not into PT don't have nothing to worry about. And those who are already doing in performance training, who have a good experience in performance training, don't think it will be boring for you, because PT is everything a new thing. Even when I do the performance tuning, every time it is a new thing for me. So there's nothing you will get bored. We will try to have much labs based on, because PT is only based on labs. As much as we do, we get to know the basics, the approach. So the approach matters when we do a performance tuning. The approach matters. The approach matters in the sense means, how do you start with the PT? The very first thing is, you should know what is the problem. Where where is the problem is the next thing, but we should know what exactly is the problem. When we know the problem, then we can go to the next step to understand the problem. What exactly is the problem it is, and when we know what is exactly the problem, then we know to where the problem is, whether it is at the database level, whether it is at the query level. So we need to be clear what type of, where it is that the problem is lying, and then we can start doing the analysis based on our experience, based on the approach, which which views we should query, or which reports we should start and analyzing it, and what all other things are available in Oracle database, which can utilize, what queries we need to write and how we need to write, so that we get a clear idea. Because until unless we don't know what is the problem, where is the problem, how the problem has started, we cannot go in the right direction. So these three things are very much important as per me. So when we know these things, we can start on the right direction. When we go in the right direction, step by step, we can start analyzing it. So once we start analyzing it, we get a clear idea or clear picture where the problem is and what kind of problem it is. Then we can drill down to the solutions, because until unless we don't do the correct analysis, we are not going to get the correct solution for it. So this is what uh, I, the approach should be, that whenever there is an issue, we should be cool, and we should first know what exactly the issue is. Because most of the times, those who have already been doing the performance training, they will agree with me. Whenever the performance issue comes, or it is observed on the system, they will come to hear that there is a database performance issue, the database is running slow. So whether really the database is running slow, it could be, it could be that the database is really running slow. It could be that there could be some application issues that could have led to the performance issue for the application. The database is fine, but the application has some deployments, some kind of changes that could have led to the performance issue. There could be some network latency. There could be some uh, resource consumption, high resource consumption on the server itself. So everything is kept is pushed to that deviate, that the database is slow, the database is not performing uh, now. So you need to look at it. So now this is the situation. We need to know what exactly is the problem. Whether the entire database is slow, whether the entire application is slow, yes or no. If it is yes, then of course we need to look at start looking at the database first, at the server level first. If the answer is no to the question that whether the entire application is slow, if it is not, if it is a specific to a module or specific to a page, then the database cannot be slow. It could be that there could have been some changes to that specific module, to that specific page. It could be either package or procedure. It could be either the front end designs, some changes which could be, have led to the performance or the slowness for that specific part. So that is to be identified. Because if we don't identify those, if we don't question to the team that what issue exactly you are facing it, where the issue you are facing it, we cannot blindly start straight away analyze the database. Because if It will take entire, it might take entire day, your entire day, and you won't come to the conclusion that is what the database is facing the issue. So that could lead to a chaotic situation that the DBA is not finding the problem, where the problem is in the database, what is the problem, and they're not giving us the solution, that what they're going to do next, so that the performance, we don't face the performance issue the next day. So we'll talk about everything. Technically, we'll do theoretically, we'll do the lab. It will be completely lab based, and then I will share my experience, what are all experience I have when I was working with the client, the client's location. So what experience I have with them, how we try to analyze it, what situations we have been into, I've been into. I would say those. So that will help you to those who are not into PTE already. It will help them to understand the scenario, the situation, and how you need to deal with it. So uh, with that, I will start with the topics which we have. So we'll start with first the database architecture overview, how the database looks like from inside. What are the components of the database? What role they play and how important they are? What is the which part of the database component plays an important role into the database performance? Okay, we'll look into that. Then how the database works is that internally when we say do a query any table, whatever it is. It could be any SQL statement, it could be any PL statement. So, and when we log in to the database, so next, what is the next step the database does? So we'll look into that. So then that will be the third, table and index structure. Now, those who are already into the performance tuning, they might be knowing it, that the table and the index structure is very much important when we are dealing with the performance issues. So once, if say if your application is in a design phase, at the very first stage, it is in the phase one, when you are designing the table structure, when you are designing the index structure. So we should plan down the line 6 months, that when the database is live, the application is live, the applications should, that design, the table structure design should be in such a way that it can handle the load for the next, at least for the 6 months at least, based on the what the client is expecting, the data growth or the users of the application. It could be more than 6 months, that after 6 months you can start seeing some of the performance issue. But if start facing issues immediately after a month or 15 days or 2 days, sorry, 2 months, then of course there is some mistake done at the very first phase at the table design, then it is a completely rework. Now when we talk about the index structure, so initially when the application is designed, we cannot be futuristic that what how many indexes we could need, what should be the index structure. So basically, at least the primary keys should be there in the tables. But most of you have you must have seen. I have seen myself that there are certain tables which, based on the requirement of the application, the tables cannot have those uh, unique columns to be identified to. And maybe it's due to some design of the application. So how that needs to be taken care of, what should be the indexes then for those tables. So initially, for you can have few indexes for those tables, and based on the users, based on the analysis of those tables, later on the indexes can be created based on the analysis done by the DBA. uh, then at the table internal structure, when we design a table, we write a create statement, we write column names and all those stuff. Then what is the at the table, there is some storage parameter we need to specify. So whether we can go with the default values, or whether we should have values pertaining to our application needs, application requirement. So whether we can take a column on the starting phase, or shall we take a call of storage setting the storage parameters for table and indexes once we have a load on the database. So we'll talk about all those things in this part. Then the fourth is related to uh, understanding the SQL structure, means the SQL queries and the PSQL structure. So first, we in SQL structure, we will talk about how we should write the SQL query. I'm not teaching the basics, but as you all are into the DBA development, well, you know about. But you will find some of the issues somewhere. The query, the SQL query which has been written is causing the causing the performance problem on the database. Now that SQL query has to be rewritten again or has to be made changes. So that goes to the developer who has done the development for that SQL query. So that is a rework. So the very first time when we write a query, we know what is the application requirement, what is the requirement for that specific application or module, maybe. So we can think of it down the line. Being as a developer, I have worked on data migration from Oracle to Postgres. So we used to migrate a huge amount of data. So we started with writing simple SQL, simple queries, simple stuff. It used to take time. Then we did the performance tuning. Then it brought down the execution time drastically. So that was a rework. So we were not clear on how we need to write those SQL queries. So that gives an experience that yes, when you're writing an SQL query, so when the data grows, that SQL queries should be capable of finding those queries. So what are the basics which we should follow while writing so that we don't have to do the rework. Again, same with the PSQL query. And the basics of in basics of query training, we'll talk about again. You can see that based on the requirement, we tend to use unions. So whether we can avoid writing unions, then when we are doing the joinings, most of the persons have done coding or were already into performance tuning, they must have observed that the number of tables which we have in our query, the number of joins are all due to some or the other reason, the number of joins are more than the number of tables. That leads to the performance issues. So how we should deal with those? We'll talk about those in the basics of query training. Then coming to error and exception handling. Now you will talk about what this is for a DBA. The reason being, if you are doing say getting a performance that is my that this job is not running properly or had or has a performance issue which was running as per the requirement previous day. Now it is not running, and now you need to analyze it. And when you start analyzing it, maybe some development team member who has already done it, he will explain you the entire logic of what this package is doing. But when you want to understand where it is failing, why it is failing, if exceptions are not correctly handled, and you don't catch the correct errors at the correct line numbers where it is failing, then that brings a lot of issues uh, uh, to analyze it correctly, to find the query which is actually causing the problem, or what the error that system is facing, the package is facing, what is the kind of issue it is having. So if we have the exceptions correctly handled, helps lot of it helps a lot to the DBA to analyze and identify where the problem is, within the package or procedure, whatever it is. So we'll talk about undo and temporary table space management basically. So how the undo table space plays an important role in performance tuning, and how we manage the undo table space. Then same with the temporary. What is the purpose of the temporary table space, and how do we manage the temporary table space, and how what role it plays in the performance tuning. Now this is also for the developers who do the coding. So the developers should know when I'm building a logic, when I'm writing a code, I'm building a logic into a code. So the way I should build up in such a way that it doesn't create a performance issue. Maybe I might not be knowing what the data count it will be reading down the line 6 months. But if I write in a proper way, if I a- avoid doing a lot of sortings, you must have observed, or you must have seen that who have done the performance training, that you must have seen distinct being used in select statements. And say suppose if it is updated with some conditions which has subqueries with select, then it has the distinct. When you're doing the distinct, then you are again you using the group by, you are using the order by. So it starts creating performance issues when the data is more on the to be read by that is specific query. So now you need to analyze what is the problem with that specific query, where it is finding the issue. The query might be good, but as the data is huge, and you're doing a distinct, you're doing a group by, you're doing order by, and then it is going to take a lot of your temporary blocks to do the sortings. Similarly, when you're doing the DMLs, then how, how you're writing the DMLs so that the the data which is getting generated, how you're committing the data so that the data is not consuming your most of the undo extent, because there will be a lot of other sessions doing the DMLs, so that other sessions don't fail due to the blocks consumed in their undo table space. So how we can manage that? So, as a developer, when we write a query, so we should have that in mind, that when I'm writing a select query, how it is going to consume, what effect it is going to have when I write distinct, when I write order by, when I do a group by. It is not that we should not use that. If it is required, we need to write. But whether can we tune it, and how much possibilities that it is that we can optimize that. Then partitioning and table reorganization. So in partitioning, we'll see the options to partition, the methods of partition, what are the types of partitioning, which partition should be which we should go with when we get a requirement to the partition a table. Now, why do we need to partition the table? That is one thing. When we talk about table reorganization, means when your table has grown big, and now that could cause an issue. So either we can do a partitioning, table reorganization. We'll talk about different ways, different approaches available in the Oracle database to reorganize the table here, reorganize the table spaces. We'll talk about DBMS redefinition. I think most of who has done the PT, or who has into the development have good experience, they must have heard about this DBMS redefinition. So we'll talk about that. Which approach should we use? Whether we should go with DBMS redefinition, or we should have a different manual approach to reorganize our tail, and why do we need to do that? So then the third last will be redo data and monitoring. So we'll talk about how the redo the data plays an important role into the performance issues, and why redo the it is always, you must have heard that your uh, job, which nightly job which was running, is not still running, it is not still completed. The stipulated time which it should have done, it is still in progress, it has not completed. So start talking about how much redo has got generated. So look at those specific part, or whether there are other queries, jobs which have been running, and they have been creating a lot of redo data, whether that could lead to performance issues. Okay. And we'll talk about the AWR report, ASH and ADM report. In AWR report, what portions of AWR report we should start figuring, because it is a huge. Those who are in into the DBA, they know it's a huge report, and going through the every part, every section of the AWR report is going to consume a lot of time. It may go to the days when you start reading, going through the AWR report. So, which specific part we should start with to start analyzing the AWR reports? When we face the real-time issues, how we should start analyzing it, which part of the database or the system we should start analyzing it, and when the issues has already occurred and it has passed, now we are hearing that there was an performance issue last night or a few hours back. So which part of the AWR report we should start figuring out? and then ASH report, then we have ADTM reports. So we'll create the performance issues in our labs. We'll generate the ATML reports, the ASH reports, the ATM reports, and we'll figure it out what is the finding by the database. Of course, we'll not be having a huge database size, use table sizes, so it would have a very small amount of data. But yes, at least we can create some issues, some contents on our lab database, and we can figure out what the AWS reports us, what findings it has when it is in real time and when it has already passed. So which part of the AWS report we should figure it out. Now, when that is with respect to query training. When we talk about how the AWS we should analyze which part of the AWS report, that helps in the database parameter performance tuning of the database parameters, which plays an important role in the performance tuning. What how we can tune the memory structures of the database. Which part of the AWS report does AWS report gives an idea to us how we can tune our memory parameters like the parameters, the PJ parameters, the other important parameters which plays an important role. So let me know up to here if it is clear to everyone, or shall I repeat again, or whether I'm going very fast or slow. Let me know.
Yeah,
Yeah,
it's good. I mean, yeah, it's good. There's no.
thank you. So all these are the chapter names which we saw, the 10 chapters. Okay, and those who are into development, as working as a developer, they might have at this very starting stage of your career, you must have seen, or you must have been asked to know about database architecture. But then after you're not into that field, that looking into database architecture, what are the components, and whether we should keep in mind those things or not while we are coding it, or how much it is important being as a developer to know about those things. So as for me, it is important because uh, I've been writing automating most of my DB activities, monitoring DB and DB activities. So when I write an SQL query, when I write a package or a procedure for my work to get automated, I always keep in my mind that the query should be written in such a way that it doesn't impact, because I'm writing a PLSQL package for my purpose, for not to do repeated works. Like if I have to do some analysis of database growth size, table space growth size, I need to analyze the impact on the database. Reading the AWS report is a different thing. But before that, if I can have some ideas on what is the load on the database, so I will keep on querying the databases, data dictionaries. So when I'm writing it, whether that queries are going to bring an impact, they won't bring an impact on the database. But yes, that should be in mind whenever we write it. Being as a developer, when we start coding, that should at least 1% that should be in mind, that my queries shouldn't impact other parts of the application or other parts of the database. So knowing it, we'll discuss about what are the components of memory structure and how it plays a role into it. Now, when I talk about memory structure, we have components of memory. We have the SGA, we have the PGA, then we have buffer pool, then we have shared pool. We'll talk about what is rack instance, what is single instance, but that is transparent to the application. That is transparent for the developers, the front end developers who are developing the code, the business logic. They're not aware whether the database is a rack instance or whether it is a single instance, because they're not writing code in that fashion. That is not required at all. The database is capable, Oracle database is capable of handling those requests onto the database. So, but still, we'll talk a bit about rack as a single instance. What basically the component wise, how it looks, what are the components, and how actually the rack instance looks. And then we'll talk about shared pool and buffer caching. This is very important when we do writing a SQL query, writing a PLSQL code. So if you are a good developer, uh, or when you are a fresher, when you start, you must be hearing that when you write a query, you shouldn't hard code it. So what if I do hard coding? So as most of them are here, experienced guys, they know that what is the benefit or the disadvantage of doing a hard coding, and now how the SharePoint comes into a picture when you write a code, be it SQL query, be it PLSQL codes, and buffer, how the buffer cache plays a role into the performance tuning, and whether when we write any SQL queries, should we consider those things when we write a SQL query, whether my query will be the uh, database will be reading it fast, or whether it is going to take time for my database to write. So how the set code will play into a role in this, how the buffer cache is going to play a role in this. uh, we'll talk a little bit on in database architecture overview. What are these components? Why are they important? And how they play an important role in performance training part. And how the database works, as I explained earlier. So we'll see it. How database treats a user request when a user request is received by a database, then what next step the database does, and the functioning of the database engine, like SQL and the PSQL engine, how it functions, and then how database utilizes the memory settings. Memory settings in the sense means the SGA, the PG, and other memory settings. And then we'll talk about in table and index structure. As I said earlier, the components of the table design, like the storage parameters which the tables have. Generally, we don't write those, but why I'm talking about will come to know when we do the labs in real time. Uh, which part of the table design storage parameter, the storage parameter which you see when you see, if you're using any PSQL developer or SQL developer, or when you generate a DDL of any table or any index, you'll find that you have created statement, then you have the storage where it has some uh, other parameters. So we'll talk about which parameter we should tune, and at which time we should tune, and how whether they actually play a role in the performance tuning for a query. We'll talk about that, and then uh, same thing. We're understanding how table and index design impacts queries in terms of their storage parameters, and how we should design the table, whether we should have all uh, the columns in a single table, or we should have normalized table structure. What is the reason for that, and what purpose it plays? And same with the index, how we should create an index. What should be the columns used in the index, and why it is an important part to know which columns should be right or should be indexed. And then the types of index and the impact, like the bit tree, when we should have a bit tree, and why, and why not be bitmap. And if you're having a bitmap, then what is the impact of the bitmap tree on any table. So you must have heard, and you must be doing those things. Like you don't use a bitmap. Basically, you're told that your bitmaps will not be used on the OLTP systems. Basically, those are for the database warehouse system. But still, we need to use. But where do we need to use, and what benefit it plays in the performance tuning? We'll see that. That's what when and why index should be created. We'll talk about, and then how many index should be created. You must have seen a table having if it is a huge table, which is a very volatile table, which is used throughout the application, maybe. So you will find, and say suppose an application, a single application has say 5 7 modules, and and that table is the heart, or is the core of your application design, or of your application functioning. So you will find for Every requirement, there is a requirement that to create an index on this table, sorry, on this column on a particular table. So when the performance hits that table, you will find there are lots of indexes on those tables. There are 10, 12, 15 indexes. So do we really need those? Or do we need to have a specific to a requirement whenever there is a performance issue, or specific to a module? Does that really needs? So we'll talk about that, how it impacts, and what strategies and how should we approach to the design of the indexes on the table. Then we'll talk about composite indexes, why do we need this, and this all about the init trans, what exactly it is, what is the init trans. Let me know, those who have already working in the performance tuning. Let me know whether init trans plays an role in performance tuning, or the queries get impacted by the init trans value of the table or the indexes. Yes or no? Those who are into the performance tuning, just give yes or no in quick yes or no. Or I will put it in a different way, that whether we should go with the default value of the init trans for tables and indexes, or we should tune the values, or we should change the values for tables init trans and tables indexes init trans. Let me know, yes or no. No. I will proceed further. In the meantime, you can just give an answer to those. Okay, coming to the query structure and understanding. So we'll talk about how SQL query is written and its impact, as I discussed earlier, and how database processes those SQL query, then the phases of the query processing. Most of will go fast with these things. These are the theoretical part, but whenever there is lab, we will do a lot of labs. Like in case of chapter number 3, we'll do it will be completely lab based. Until if we don't do the lab, there is no point in discussing theoretically for in chapter number 3. And then chapter number 4 basically will be theoretical. And then when we come at this part of importance of bind variables and the execution plan. So we'll talk about why do we need bind variables, and even though we have bind variables, do we see the performance issues? If yes, then how? And if you're saying the performance issue, even though we are having the bind variables, so where do we need to look at in the database to find the issue? And then we'll talk about the execution plan analysis. So we'll go a bit fast on the first two chapters, then we'll go deep dive into chapter number 3. Bit fast on chapter number 4, but we'll discuss deep into importance of the bind variables and the exclusive plan analysis, because that will be the basic for the next coming chapters. Like in case of query training, we'll talk about what is PSV engine, what is context switching, then how do we do the code maintenance, what is the use of global variables, what is the use of collections, so that the persons who are developers, they know why do we need to use collections, and how you do, what role it plays into your performance issue, how it improves your performance, the performance of the query. So and this the session, when we start the actual class, this will be at a both ways session. So those who are already have a good experience in PT, who have good experience as a developer, will have a 2 and 4 discussion on some important topics. You can share your experiences, you can share your approach of doing it, so that the others benefit. Okay, we'll have the two-way communication when we have sessions, because this part is very important. Those who are new into the development, or those who are already into development, but they might not have got chance to use those things. So they will come to know, yes, I'm facing that issue, but I don't know I could use these things to improve the performance of my query, so I will give a try next time. So that will help the others as well. And then we'll talk about the bulk collect and its impact on the performance. So let me know from all the participants, have you used bulk collect? when you design your queries, when you write your query. Let me know how many of you know about the bulk collect. You can just type in chat yes or no. Okay, fine. We'll talk about this bulk collect and we'll see, we'll do actual lab on it. And I will share my experience, uh, how I used this and how it benefited that ap- application. Basically, the jobs which are running at the night, and basically the month-end jobs which are run at the night, how much it benefited. So we'll talk about this. I will share my experience. I will share the way, my approach, why I will went with the bulk collect, and how this helps in improving your performance. This will be very good uh, knowledge sharing, and you will get to know that, oh, this is a issue same way which I'm facing. Let me have a try. Let me give it a try. But that needs a lot of strategies. Uh, and if it is new to you and you are going to explain to your team member or the senior person, you should take into confidence. Yes, I can test it. Let me give it a try, and let's see how it improves the performance. Then we'll talk about when to commit and not to commit. Basically, this is the part which plays a very important role when during the performance issues. You must have observed that the transactions keep on going. Basically, for the reports, when you're training any query which are part of a report, month-end report or a day-end report, you will find that the transactions keep on going, but they're not committed, or they're committed too frequently. So how are you going to analyze it, and whether that is playing a role into the impact of that performance? Then maybe most of the developers may be knowing what is this PLSQL warnings. We'll have a lab on this PLSQL warnings, what it is. Then we'll talk about the SQL trace and auto trace, how we generate this SQL trace. All of you, I hope all of you might be doing it. But reading it, we can generate, we can have a lot of reports, we can have a lot of data collected, but we need to interpret also, we need to analyze also, we need to get a conclusion out of it. So we'll look into that SQL tracing and the auto trace. What is the difference, when to use SQL trace, when to use the auto trace? Everything will be lab based. So as we do the labs, everything will be explained to you to what commands we need to write. Everything should be will be noted, and it will be shared with you. Then the AWL report, ASH, and ADDM report analysis. Now, let me get an input from the DBAs, basically, who are here working in the DB role. When you generate an AWL, do you get I used to get frustrated that if I have to generate an every hour AWL report, say for the previous 2 days, and I got a performance issue where the team is complaining that we have been having performance issues since day before yesterday from between 2 to 4 p.m. or 2 to 6 p.m. that there was a performance issue. Now we need to analyze the AWL report. So either you generate a single AWL report between 2 to 6, or you generate every hour AWL report. Does that frustrates you if it is very repeated, that you keep on generating 2 to 3, 3 to 4, and 4 to 5, and so on? Let me know, yes or no. So Ahmed says yes. Other DBS. Okay. So I have written a script through which I can just give an input value, any number. Say suppose I need to generate a AWL report for today. Say suppose between 10 a.m. to 2 p.m. So I will just pass a value to that script, and it will automatically generate for me all the those AWL reports for the from 10 a.m. to 2 p.m. I don't have to keep on writing that AWL RPT.SQL every time. So I will discuss with you. I will share the steps how I have written that uh, process that generates at any n hours of AWS report just by running that script and passing a value. If you need to generate 2 hours AWS report, say each every hour, just you will pass two. You will generate two AWS reports for every hour. Say suppose if you need 5 hours AWS report, so 5 times you need to run AWS RPT.sql. That with that script, the script which I have written, you have to just pass five, and it will start generating the AWS report for those 5 hours every hour. Hourly AWS report for those time period of 5 hours. Now, say suppose if I need to generate AWS report for a previous day, then I can pass the date and I can pass the time period. I cannot pass an hour. Okay. Even if I pass an hour to my previous script, which generates based on the hours, it will not be because it will keep on generating for those many hours. Now, if I have uh, to generate a 2 days back AWS report for say suppose any specific time period, say suppose 2 to 5 p.m. Day before yesterday's 2 to 5 p.m. Okay, so there I've written a script which is capable of generating the AWS reports for those for that previous day for those time periods. So I will share with you that and you can utilize in your labs. Don't utilize in your any of your production systems. Okay, that is this is only for your learning purpose. Then you can take on your own and learn it and improve your skills on that. So that we'll see. Then real-time performance analysis. So what we need to look at when we did the real-time performance issues. So now see, every client, those who are your who are working, do you use OEM? Do you have OEM or do you depend on some tools like SQL Developer, PSQL Developer to monitor the sessions? Let me know. Do you use OEM or do you use some other tools to have a real-time analysis, or do you use a PSQL developer or a SQL developer to check what are the sessions blocked, what actually it is going in real time in that database package? So we'll see if you don't have OEM, then what else we can use to analyze it. Then we'll talk about SQL profiling. What it is, why do we need to do this SQL profiling, and when it is required. And then we'll talk about DBS profiling. So the developers who are in the session, uh, let me know how many have you used this DBMS profiler, or do you know that this package is there in the Oracle database DBMS profile? Let me know quick yes or no, because it is already 3:50. Okay, so we'll talk about that a bit. Then tuning of the database instance. Then we'll see about analyzing wait events and the contentions and the error exception handling. Then we'll see in best practices what how we can rewrite the queries and what best we can do while writing the query. And then we'll talk about again temporary databases management to databases management. And then in partitioning, we'll talk about the concepts, the compression techniques, uh, and how it improves the performance, whether it brings a impact positive way or the negative way. The compression. Then the table reorganization concepts, and then lastly we'll talk about the redo data in a report, how to analyze and redo data analysis and the impact of it. So we'll see that there are a lot of queries which we can use, analyze, generate the data to analyze this redo data. Now for this lab, uh, you already know you can have SQL developer. You will need a VirtualBox, we need Linux, and then either you can have 12C or 19C database versions. But we Oracle already has OVA, Oracle Virtual Application, for 19C and for 23C. Okay, and uh, so you can download that 19C OVA and 23C OVA, and you need to just install the VirtualBox and just you can import that or those OVAs it will automatically install the Linux OS, and it will deploy the database also on your system, on your laptop. So that will be enough for this lab sessions uh, when we do the practicals. And let me share this is what it will be, the complete content, the database architecture overview. We'll discuss on this, what are the backend processes, how it looks, how they communicate between the two, then the rack database instances and the single instance, and then the memory components, and the set pool, the buffer cache. So we'll discuss deep into this when we start the actual class. Okay, so I will recommend to download those OVS, maybe 19C or 23C. Why I'm telling 23C is that maybe there may be new features as with respect to the performance tuning. So we'll look at those also. We'll do it on 19C. We'll do it on the 23C as well. Okay, so if you don't get the link for 19C, 23C is already there, available on the Oracle website, oracle.com. If you research, you will get that 23C Oracle virtual box application. You can download that. For 19C, if you don't find, let me know. I have with me. I will share with participants. Okay, so that's all as far as this demo session is concerned. This is what we have, and be assured everything will be lab based, and we'll be having fun learning it. And uh, this has to be both way communication. You also can share your experiences for when we do specific kind of performance tuning steps, so that it benefits all of us. It's not that it should be just one way. So that, let me know if all everyone agrees on this. Yes or no? So that's the end of that's all we have in this. I'm just stopping my screen sharing. Okay, if you want to if you have any queries, you're free to ask now. You can unmute yourself, or you can put it into chat. If you have your feedbacks, or how was the demo session, whether you liked it, or any questions you would like to ask. Okay.